this, the mins and maxes occur in three places. The reason we call this the first derivative test is the first place that we look is when f prime is equal to 0. The second place we look is when f prime does not exist. And when the third place we look are some domain restrictions and endpoints of the original function. Whoops, that should be inclusive. All right. Now, problem number 2 is kind of a challenging problem, but it's not so challenging. On the test, in all reality, if you graph the function, that's what it looks like. Okay? Now it says to find your min and max values. Well, we see that they occur here and here. I just need to prove it somehow using the first derivative test. So what I want to do is mathematically, and I'm going to do this on a separate sheet here, we're given that the function f of x is equal to x times the square root of 4 minus x squared. Well, we could think of that as x times 4 minus x squared raised to the 1/2. Okay? Well, first step in the process is we're going to take the derivative of this. Now, this is the product rule. And remember that when I want to take the derivative of a product, it's uv prime plus vu prime. Whoops. Where this is u and this is v. So if I let u equal x, then u prime is going to equal 1. If I let v equal 4 minus x squared raised to the 1/2, then v prime would be, we toss the 1/2 to the front using the product rule. The stuff on the inside remains the same. Then we subtract 1 from it. Whoops. All right. Smartboard's not being so smart today. And minus 1/2. Now remember, using the chain rule, we have to tack on the derivative of the stuff on the inside. So when I tack on the derivative of the stuff on the inside, that's a negative 2x. Whoops. So then v prime is really, what's 1/2 of negative 2? Negative 1. And then we have, so that would be negative x, if I toss everything to the front, 4 minus x squared raised to the negative 1/2. Okay? So if I do u v prime, in other words, I'm going to say x times v prime, which is negative x, times 4 minus x squared raised to the negative 1/2 plus.
Mr. Evans?
Yeah.
Why is v prime, why is it to the negative 1/2?
Okay, that's a good question. So we said that v is equal to 4 minus x squared raised to the 1/2. If I take smiley face raised to the 1/2 and I take the derivative of that, I have to toss the 1/2 to the front times the smiley face and then tack on the derivative of the smiley face. So this 1/2 here gets tossed to the front. So for v prime, I get 1 over 2 times 4 minus x squared. Then what do I do with the power?
It's minus 1.
Yeah, so I've got 1/2 minus 1 here, which would be negative 1/2. Does that make sense?
Yeah.
Okay. Good question.
Why do you always use smiley face?
Did you say you had to tack on the derivative of smiley face after?
Yeah.
So, okay, the derivative.
The smiley face represents a placeholder. If I use x and y all the time, sometimes you guys, because there's lots of x's we write down, the smiley face is a little more symbolic. If I were to write down the 4 minus x squared, there's an x in there. So if I say x prime or something like that, or dx or f of x prime and all that stuff, Sometimes it could be confusing with the x's, but it's clear when I put smiley face and smiley face prime that we're just taking the derivative of the stuff. So the smiley face represents the stuff. Now, what I have here, if I clean this up, f prime of x is equal to negative x squared times the quantity 4 minus x squared raised to the negative 1/2 plus 4 minus x squared raised to the positive 1/2. Well, I need to set that equal to 0 and solve. Yikes. Alright?
Well,
Yeah.
Mr. Adams,
That's kind of scary, huh?
what happened to the negative 2x and the g prime?
Well,
Oh,
when I do the 2x that gets tacked on the end, right, we didn't finish the whole thing. She asked a question and I answered half her question. Remember, we have to tack on the derivative of this stuff, which is negative 2x. So when you take the 1/2 and multiply it by the negative 2, v prime is negative x times 4 minus x squared raised to the negative 1/2. That's the whole derivative. That answer your question?
Yeah.
Okay. All right. So finding the 0 for this, it turns out, is not hard, but it's not easy. Yes?
Can you just plug in your calculator?
Yeah, you can just plug it in your calculator, but we're going to solve for the 0 and then plug it in the calculator. And this is like a special case, and it's a really weird one, but when you take the test, you won't have a lot of time, so you can just plug it in the calculator, okay? So if we were to plug this in the calculator, like this, it would kind of look like, it would look like this. Whoops. Now, it crosses, this is the weird thing about this. When you graph it in the calculator, I'm going to show you something very bizarre. How would I find the 0?
Second
Nice,
intersect,
so like,
or second trace and do the intersect.
Yeah, second, I would do second trace, and then I would choose 0. And then I would go a little bit to the left of where it crosses the x-axis. And then a little bit to the right, and then I would try to get it as close as I could to the thing, and then hit enter. And then we see it's negative 1.414, right? So what's that?
That's the 0 of the function.
Yeah, but do you guys know what that number is?
1/2.
Now it's not quite 1/2, it's the square root of 2. You guys got to get used to kind of memorize that. When you see that decimal, it's the square root of 2. So that's an interesting thing. Now here's what I want to show you. And by the way, if you were to take a guess, what do you think this number is?
1.14.
Yeah, it's the positive, right? Because it looks like it's symmetrical about the y-axis. All right, so here's the weird thing. How do I make this look like that? Well, if I multiply both sides, okay, there's some stuff that I don't like. And one of the things that I don't like is that I have, well, if I subtract this stuff here, I get negative 4 minus x squared raised to the positive 1/2 on this side. And then negative x times x squared times 4 minus x squared raised to the negative 1/2 on this side, right? I could do that. But generally our goal is to get all of the x's on one side, and if I take that approach, I don't know, there's a lot of interesting things that I could do. If I do it this way, it's a little more cumbersome than if I take this whole thing and multiply it by 4 minus x squared raised to the positive 1/2. Now what happens is that times 0, in other words, I'm going to distribute that through to all three terms. This times 0 is still 0, and then I get negative x squared, and a positive 1/2 plus a negative 1/2 is that stuff in parentheses, minus x squared raised to the 0, plus, and then I add the 1/2, and this becomes 4 minus x squared raised to the 1. So everything in the parentheses raised to the 1/2, we use the shortcut of just adding the exponents. And that's where we get the 4 minus x squared to the 0, and then 4 minus x squared raised to the 1. Because I'm just adding this 1/2, this 1/2 with this negative 1/2, and then I'm adding that 1/2 with this positive 1/2. So this is like 1/2 minus 1/2, and this is like 1/2 plus 1/2. That's where this 1 and 0 come from. Well, anything raised to the 0 is just 1. So this is just negative x squared, and then plus 4 minus x squared. So then if I combine like terms, I get 0 is equal to negative 2x squared plus 4. Then, if I subtract 4 from both sides, I get negative 4 is equal to negative 2x squared. You guys with me so far? Then if I divide both sides by negative 2, these 2's cancel and I get positive 2 is equal to x squared, or plus or minus 2 equals x. Whew. A lot of work. So what does that say? That means the zeros for f prime occur at positive and negative square root 2, which is what we confirmed on our graph. But that wasn't your run-of-the-mill solving for 0 type of deal, was it? That one you had to do a little bit of thinking algebraically. Now, when you take the test, I'm not expecting you to write all that out. I'm expecting you to write this down, graph it, and tell me what the zeros are. Does that make sense?
Yes.
To save time. All right. So now, okay. So if we go to the original test question, it says, where does this occur? Well, it occurs, what did we say? We said this stuff occurs when f equals 0, so, or f prime equals 0. So that occurs when x equals plus or minus the square root of 2. How can I verify that? It also says that it can occur when f prime doesn't exist. So technically I have to figure out where f prime doesn't exist. Well, that one's not that hard. If we come back here, we've got this square root issue, right? This is a square root on the denominator, and this is a square root. So I guess the domain restriction on f prime, right, is this thing here. The square root of 4 minus x squared, because that occurs twice. Well, this cannot equal 0, and it can't be, in other words, stuff on the bottom, it can't equal 0 because I have that on the denominator in f prime, so it can't equal 0. And this stuff can't be negative. In other words, 4 minus x squared has to be greater than or equal to, oh, it can't be equal to, it has to be greater than 0. Right? Now, if that's the case, then I get negative x squared has to be greater than negative 4. Divide both sides by negative 1. And I get x squared has to be less than 4, and then we take the square root. But really, this greater than or all this stuff, that's a boundary. We've got to think about that. What we're really saying is that it can't equal, right? x squared can't equal 4, so x squared cannot equal 4, or x cannot equal plus or minus 2. That's the problem that we run into. And then there's some inequality stuff. But we're just interested in where it can't be, right? So I think we're okay, but we're really curious about x can't equal plus or minus 2. So if we come back here, and you'll see how that relates to our issue. So I said that it can't, x cannot equal plus or minus 2. And then the other thing that I kind of skipped over, but I probably shouldn't have, we were able to solve all this stuff by doing some fancy math, right? But another approach that well, let's look at the graph. It's clear in the graph. There's only 2 zeros on our equation. This is f prime that I have on the graph, right? So there's only 2 zeros, and then we found that there, on our original function, there was an issue where x could not equal 2 or negative 2. And then we know there's an inequality component, which means it can't be, and I'll tell you what it is, and you'll see why when we look at the graph. It can't be greater than 2, and it can't be less than 2. Right? So, what does all this mean? Well, if we graph the original function, which is this one here, and I'm going to turn off my f prime, this is what we're trying to find the minimum and maximum values of. This is the original function. Oh, I highlighted the wrong one. Let me go back here. That's f prime. Oh, I didn't turn it off. So you can see it both. The green line is the original function. And so what you see here is that when f prime is 0, that's where we have a minimum value. When f prime is 0 here, that's where we have a maximum value. So at negative square root 2, we have a y value of, let's find out. Oh, wrong function. Let's just do trace. Oh, wrong function. Negative square root of 2. And that's negative 2, right? And over here, we would have root 2 comma 2, if we plug that in. Okay? So what was the question they were asking us to do?
Use the first derivative test to determine the local extrema of the function and identify any absolute extrema.
All right, so what are the absolute extrema? Well, this is negative root 2 negative 2, which is the min, and it's the absolute min. And this is the absolute max. Now, the only issue is that the online test, when I post the online test, something went wrong, like I forgot the negative sign. And so that isn't one of the options on there, is it?